Hello, in this objective, we'll look at finding the greatest common factor of a list of numbers, find the greatest common factor of a list of variable terms. We'll also factor out the greatest common factor, and we'll factor by grouping. Let's take a look at the steps to factor the GCF. And to find the GCF, or the greatest common factor, the first thing we'll do is factor. We'll write the prime factorization for each numbers in our list, or each quantity in our list. The second step is we'll list the common factors. The third step is if variables are involved, we'll choose the least exponent on the variables. Lastly, we'll multiply to determine the greatest common factor. So let's take a look at an example. And in this example, we're asked to find the greatest common factor between 36 and 60. So I'll simply do a prime factorization tree for both. I'll determine the factors that are common to both, and then we'll find the greatest common factor. So we'll find the prime factorization for 36. And here again, I'm going to use a factor tree. I'm simply going to find two numbers in which we multiply to get 36. Once we reach a prime number on our branch, I'll simply circle it because that's where that particular branch will end. So for example, 36 can be expressed as 2 times 18. 2 is a prime number, so I'll circle 2. I'll continue to break down 18. We can factor 18 as 3 times 6. 3 is prime, so I'll circle the 3. And we can factor 6 down into 2 times 3, which are both prime. Therefore, the prime factorization of 36 is equal to 2 times 2 times 3 times 3. Next, we'll write the prime factorization for 60. Once again, I'll use a factor tree. We can express 60 as 2 times 30. 2 is prime, so I'll circle the 2. We can express 30 as 3 times 10. The 3 is prime, so I'll circle 3. And we can express 10 as 2 times 5, which are both prime. Therefore, the prime factorization for 60 is 2 times 2 times 3 times 5. So when we determine the greatest common factor, we'll simply find the factors that are common to both factorizations, and we can see that a 2 is common to both, another 2 is common to both, as well as a 3. So we'll simply multiply those numbers together. 2 times 2 is 4. 4 times 3 is 12. So our greatest common factor is equal to 12. Now we'll look at another example. We'll find the greatest common factor for 12x squared and negative 30x to the 5th power. So now we'll factor 12x squared and 12x squared. By using that factor tree, we have 3 times 4. 4 breaks down into 2 times 2. So the prime factorization for 12 is 2 times 2 times 3. And I'll break x squared down into x times x. Next, we'll look at negative 30x to the 5th power. Since this quantity contains a negative, I will simply factor out that negative. We can express 30 as 3 times 10. We can express 10 as 2 times 5. Therefore, the prime factorization for 30 is 2 times 3 times 5. X to the 5th breaks down into x times x times x times x times x. If we determine the factors that are common to both, we see that a 2 is common, we see that a 3 is common, We also see that two x's are common to both. Therefore, the greatest common factor is 2 times 3 times x, which gives us a greatest common factor of 6x squared. In this example, we'll factor 3x to the fifth minus 15x to the third power plus 6x squared. And if we take a look at our coefficients, 3, negative 15, and positive 6, they all have a common factor of 3, so I'll factor out 3. Next, I'll take a look at my x variable, and I'll locate the smallest exponent for, in this case, the x variable. This x is to the fifth, this x is cubed, and this x is square. So the least power on x is x squared, so I'll factor that out. And now I'll determine what's left on the inside of my parentheses by multiplication. So 3x squared times what quantity would give us 3x to the fifth? That would be x cubed. 3x squared times what quantity would give us negative 15x to the third? That would be negative 5x. And lastly, 3x squared times what quantity would give us 6x squared? And that would be a positive 2 for our factorization. Let's take a look at another example. And in this example, we're asked to factor w squared times z to the fourth minus 3 plus 5 times the quantity z to the fourth minus 3. Taking a look at the setup, we have an expression in two terms, our first term and our second term. If we take a look at both terms, we determine that z to the fourth minus 3 is common to both terms. So I'll simply factor that out. Z to the fourth minus 3. And in the other set of parentheses, I'm left with w squared plus 5 for our factorization. Now we'll take a look at the method of factor by grouping. And when we use the method of factor by grouping, we factor a polynomial with 4 terms. So the first step is we'll group the terms by placing a set of parentheses about the first and the last 2 terms. We'll factor out the greatest common factor for each term or within groups. We'll factor out the greatest common factor for both terms or the entire polynomial. And if necessary, we'll rearrange all of the terms. In this factor by grouping example, we will factor 10a squared minus 8ab plus 15a minus 12b. So I'll simply group the first and last 2 terms with a set of parentheses. I'll now factor out the greatest common factor for each term. So the greatest common factor for 12a squared minus 8ab, if we take a look at our numbers, 10 and 8, the greatest common factor is 2. There's an a to the first power that's also common to both, so my greatest common factor is 2a. So inside the parentheses, I'm left with 2a times 5a, which is 10a squared, minus 2a times 4b, which gives us negative 8ab. Now I'll factor out the greatest common factor for our second term. The greatest common factor between 15 and 12 is 3. Notice that there aren't any variables common to both. So now I'll determine what's left over in the inside of our parentheses. Therefore, 3 times 5a gives us 15a, and 3 times negative 4b gives us negative 12b. And now I'll factor out the greatest common factor for both terms. The factor that's common to both is 5a minus 4b. And in the second set of parentheses, I'm left with 2a plus 3. In this example, a factor by grouping will factor 6x plus 4xy minus 10y minus 15. So the first thing we'll do is group the first and the last two terms within a set of parentheses. So we have 6x plus 4xy. Since my third term is negative, I'll factor out a negative, which will in turn change our signs. So the innermost of this parenthesis contains a positive 10y plus 15. Now we'll factor out the greatest common factor for each term. The greatest common factor between 6x and 4xy. The greatest common factor between 6 and 4 is 2. There's an x to the first variable that's common to both, so we'll factor that out. Now we'll determine what's left on the innermost parentheses. So 2x times 3 gives us 6x, and 2x times 2y gives us 4xy. I'll factor out a 5, which is the greatest common factor for our second term. 5 times 2y gives us 10y, and 5 times 3 gives us 15. So now we'll factor out the greatest common factor for both terms, which in this case is 3 plus 2y, which is also the same as 2y plus 3. So we'll factor that out. And in the other set of parentheses, we're left with 2x minus 5.